Hi guys, welcome back to AI with MJ, and this is the Leetcode's Interview Crash Course for Data Structures and Algorithms. In the past few videos, I've been done the introduction and one of the data structures, arrays and strings. So today I'll be doing hashing, and then we'll do checking for existence, this module, along with like one or two problems depending on how much time we are left with at the end. So as usual, the video is not going to be longer than the 25-minute limit, and let's get started. All right, so what is hashing? This in the most basic term, a data structure is format for organizing data in an efficient way. In practical terms, we can split the data into two things, the interface and the implementation. So the interface is like a contract that specifies how we interact with the data structure. So for example, like if we want to put anything in the database or like remove it, and basically how we use that data structure. Like in an array, we would do like add in the array or like push in the array or like delete from the array. So an implementation is like what code is written that actually makes the data structure works. So this is where the details of how the data is stored and how the operations are performed come into play. So it could be like how much memory does it take, how long it is, rearrange the elements, and what operations like remove is called. So for most of them, the implementation is quite complex, involving like intricate algorithms and data manipulation. But we don't have to worry about this for in terms when using hashing. And in this one, we're just gonna like implement hashing. With hash is basically a function that takes an input and deterministically converts it to an integer that is less than a fixed size set by the programmer. Input are called the keys, and the same input will always be converted to the same integer. So this is an example of an hash algorithm for a string containing letters of English alphabets. So we know that like there are going to be only 26 total characters, and then we can take that value and multiply it by the current position in the string, that is index plus 1, because we start with 0 index. Add this to total. For example, if this is the string ABC and B is at position 2 in the alphabet and position 2 in the string, so it would contribute to be like 2 into 2, 4. So that is the total. And after going through every character, total is the converted value. So this could not be a very good hash function, obviously, because like it's very simple and there could be like collision and stuff, which we're going to talk about in the future. So yeah, that is how you can like define the hash function. Like every key will be unique and it will have a value. And that is what this is basically is. And what's the point, right? Like, so here it just says that we have like O of 1 time access in the arrays, and given an arbitrary index, we can access and update its value in the array in constant time as well. So the main constraint with arrays is that they are fixed sizes and the indices have to be integers. But hash function can convert like any input into an integer. So we can remove that constraint that it only has to be an integer to do it. So it can be combined with an array. It creates a hash map or a hash table or a dictionary. And with arrays, we map indices to values. With hash maps, we map keys to value. So like keys could be anything. And a key can, yeah. Typically, the only constraint on a hash map is that it has to be immutable. So it also like depends on the language. But yeah, in Python, we just like use dictionary, and in dictionary there is quite a few implementation. For example, like default dict or like structured dict or ordered dict. So we can get into that later. And hashmap is an unordered, like it does not carry any order data structure that stores key value pairs. You can add and remove elements in O of 1, as well as like look for any key in O of 1 as well. So that is that. And then this is just like what is the comparison with A. So add an element and associate with a value. While like we can delete an element if it exists, checks an element. So this is what we can do in Hashmap, and it also can find the length or the number of elements, update it, iterate over elements. So that is pretty easy to understand. This just goes over like the relative complex time complexity. Usually most of the operations are done in O of 1, except like appending it. And this is a set is another data structure that is very similar to a hash table. And it uses the same mechanism for hashing keys into integers. The difference is that in a set, they do not map their keys to anything. Sets are more convenient to use, and usually you use it for like lookups and you don't want to store any extra information about a particular element. So basically, it can only have keys and no values. So that's when it becomes a set. And we said that yeah, you can put like arrays as key, but like I think in Python you have to put into a tuple because they are immutable, and we want our keys to be unique and like not mutable. Hence, we convert it into tuple and then put it in the array as a key. And this is just like interface guide. So like a hash map, you can initialize it and then check like if something exists, you can access the value using like the index number. We can also like update or add, like if you at index 5 want to put the value of 6, we just put it in this notation. Then if it does not exist yet, then like a new key value pair would like be created. We can delete using del. We can find the length of the hash map, and to like get the keys, we can use like dot key function in the hash map, and it's a built-in thing, so we can just call it. And same for values. I think there's also a get function, so that get function can get both key and value at the same time. So yeah, this is just the playground. Let's go. This is the first module, which is checking for the existence. So we just have to check, like determine if an element exists in O of 1. Since an array needs O of n to do this, using a hash map can improve the time complexity. This is a very basic like two sum problem. I think this is also like the most frequently asked question like by the companies. I don't know how like what interviews people get this question in, but if you are someone who saw this, please let me know. Like 176 times in the past 3 months at Google. Like, man, I just want to know what would be the follow up for this. But anyway, moving on. Oh, actually, just since we are at this topic, I've seen like Meta ask like a two sum domino question, which is like a 2D array kind of thing. But yeah, irrelevant right now. So this is like everybody knows it. This is like the first problem on Leetcode as well. Basically, like there, it's not a sorted array, and we just have to find like if there are any two elements that exist in the array that will like add up and make like meet the target. So we just create like a hash map, and what we're doing is like if suppose like every element is stored in with the indexes, and then if you at any point see like a complement that is like the target minus the current index you are at, then if the counterpart exists in the dictionary, you just like call and give the indices. But yeah, this is like one of the most easiest problem you can ever solve. And this is like next example, first letter to appear twice. So basically it's like if you have like ABCC, you just have to find like if there is any element that you have to find again. Like for example, C exists twice. So if C exists, then just return that element. So here we can just use a set, just because like we don't really care about the index, I think. Oh yeah, I don't think we have to care about the index. Yeah, so we just like use a set and then we go over the character in that set, and then if that character has been seen before, we just return. Yeah, this is not a very common problem, but basic to understand set. So that is it. And then this example is like given an integer array nums, find all the numbers in nums that satisfy the following condition: x plus 1 is not in nums. Oh, actually, this is a question that I've been asked in an interview before. It just said that like if you start from zero, just like if which number in sequence does not exist. So we again like create an answer and then we make that set numbers so that if any element is like repeated, now it's just one time. And then we go over all the numbers in set and we check like if +1 exists and if like -1 also exists. And then doesn't, if it does, we like append it to the answer and then we return the answer. Okay, this is a different problem than what I was talking about, but basically you're just appending rather than like checking if an element exists. Yeah, if like X appears multiple times, you only need to include it once. So the set is just already doing the job for you. And here you are just forming the sequence of that. Okay, moving on. So this is one of the practice problems for this particular topic. And let me just clear it out. I've solved this before, but I don't remember. Okay. What is a panagram? So panagram is a sentence where any letter of the English alphabet appears at least once. Okay, that's easy, right? Like, for example, given a string containing only lowercase English characters, return true if a sentence is a panagram. So what we can do is we can have a scene equals set, and then we can maybe initialize it with A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I don't know if you have to like, I don't think you need to space it out by commas and then go over every character in the sentence, right? If character not in scene, return false. And also, like, for example, let's say if count is beyond 26, right? Actually, we can also delete it. If character not in scene, then we just return false. Otherwise, we will go ahead and remove scene dot remove that element so that it decreases. And if it all goes well, we'll just go ahead and return true. Oh, sentence. Why did it return false? We don't need this count, and if the character is not in C, or maybe because like I think you have to hold on 1 second. Check pentagram and or we can add it. Actually, like let's not initialize the set like that or like remove it because it's just causing a little bit more complexity. What we can do instead is we can have a set and then like if like that we can just keep adding it, right? Like this scene dot add character. And if at any point, like, we only return true if like len of set scene is equal to 26, just because like it should have all the characters and we don't need this. And we only add like if the character is in this range. So if A is less than or equal to character less than equal to Z. And then there. Yeah, this is like pretty easy, fairly easy actually. Um, we can also do like just convert the sentence into a set, and if the length is equal to 26, then that is the answer anyway. That's one way. And also like the for earlier approach, for every character, we just check if that is an alphabet, you remove it. And then if the length of the set is 0, then you return true or false. So that should have worked too. My bad. Alright, this question is done. Moving on, missing number. Okay, there we go. I think this is the problem. So given an array numbers containing n digits in the range 0 to 1, return the only number in the range that is missing from the array. This was what I was talking about earlier. I'm not gonna like solve it again, but basically what we did is like we created a set and we converted this number into the set. And then we just went through everything, and then if the current number, we're going from 0 to nums plus 1 because I think in the constraint, like it starts with 0. So the next number has to be 1. So if that is not, then we just return that number. Okay, that was fairly easy. And then counting elements. Okay. Let's see. Not a very common question, but let's do it quickly. Given an array, count how many elements x are there, such that x plus 1 is also in the array. If there are duplicates, count them separately. Wait, what? Given an integer array, count how many elements x there are such that x plus 1 is also in the array. Oh, okay. So, for example, like there is no 2, so there is no, like we don't count. Then for 3, there should be 4. So that's not there, 5 plus 6 and 7. Okay, so what we can do here is like, we can maybe have like a hash map which will store like count of all the elements in the array. So this will be like 1 appears 2 times, 3 appears 2 times, 5 appears 2 times, 7 appears 2 times. And then we go over the hash map. So for element in hash map, dot yeah, so we're going over the element, and here we also have to do like count, right? Because that's what we were returning. So let's just return, before I forget, return count. And for element in hash map, if element in element plus 1 in, and also this would be dot values, because sorry, it will be dot keys because that's what we're looking at. And if key, if index for I in range hashmap dot key, if element in hashmap, element plus 1 in hashmap, then increase count plus equals 1. Otherwise you'll just return 0. Oh, is it keys? Ah, hide this one. Yeah. Oh, because so I think instead of like going, so we'll do count plus equals hashmap of keys of I, because that is the value we need to add. Yeah, makes sense. So basically, if they said, right, that if there are same elements, then count them twice. Anyway, if there are duplicates, count them separately. So we know the count of the duplicate, and then since that existed, we just add that to the hash map. Okay, I think we are about time, and we did finish one of the modules here. So I think we did pretty well. For the counting part, that was what I'm going to be doing next in the video. But yeah, this is like one of my most favorite courses for not randomly, but for revising like DSA pattern wise and according to data structures as well. So yeah, if you have like any feedback or questions, please let me know. Happy to help. Thanks for watching.